All right, we'll see how far we get today. How are you guys doing? Are we tired today or yeah? No, you're good. Ryan's good. Okay. I'm definitely wiped out from this week. The Wednesday night back to school night is not a good plan. It's too long of a day yesterday. So all right, so we're talking about univariate data. This is our first unit. So we're just talking about the very basic piece of statistics, and that's just collecting data. So first, we always have to talk about where our data is coming from. And we will talk about the population. That is the entire set. Sorry. Of individuals or objects. Being studied. And if you can't read something, just let me know. I'm always trying to squeeze things in on these notes, so if it's too small or you just can't read it, I won't be offended, okay? Just ask. I think a lot of times when we're talking population, we think people, that's the population it has to be. Your population does not have to be just people, okay? It can be any sort of set of objects, so just make a note, not always people. And we'll do some examples where you define what the population is. All right, and then from the population, you generate what's called a parameter. So the P's always go together. So parameter goes with population, and you're going to always see this with a Greek letter, almost always, I should say. This is the only one where we don't use a Greek letter. The population size, sometimes we see that with just N, but it will be a capital letter, okay? All right, guys, then from the population, that's where you can draw your samples from. So a sample, it's just a smaller subset of that group. So we'll say it's a subgroup of the population. It's usually very inconvenient to run an experiment or collect data from the entire population. Like if you think about the census, that's not something that happens all that often because it takes a really long time and a lot of resources to do. Or if you're running an experiment, like think about vaccine trials. You don't give this to every single person when you're doing a trial, right? You have some sort of sample subgroup that you're looking at, okay? So that's what we do with a sample. And this will generate a statistic. So parameter with population, the P's go together, and then statistic is from your sample. The S's go together. We have the capital letter N for our population size. For our sample size, we always use a lowercase n. All right, we got to make sure we understand what type of information we're collecting. And there's two types. There's quantitative and categorical. So quantitative, sometimes it's also called numerical. It's usually a numerical value. And another way to think about it is taking the average makes sense. So if I'm asking you to identify a variable as quantitative or categorical, you could look at the values you get from it and say, okay, would it make sense to average these different groups? And if that makes sense, it's probably a quantitative variable. If you like categorical, this is non-numerical groups like different colors. So we've sorted you into red, green, blue, and yellow. You can't exactly average red, green, blue, and yellow. Okay, so that's a categorical variable. So if you're stuck on that, just think about would averaging it make sense. So categorical, that's the other one. Sometimes it's called qualitative. And with this one, the answer to a question is usually a word, not a number. And we'll go through some practice where I give you a bunch of different variables and you identify whether they're quantitative or categorical. And when you have a categorical variable, you can calculate a proportion with that. So your proportion is just the number of successes that looks like a really weird word to me right now, over your sample size. We would note that just with x over lowercase n symbols. Yeah, go ahead.
What constitutes a success?
Yeah, so it'll be defined in whatever the problem is. Like, it could be as simple as we're flipping a coin and tails are considered successes. So, you know, it can be really basic like that, or it can be something much more in depth, but it'll be defined in however you're looking at that proportion. So, good question. Okay, symbols. We have a ton of symbols that we use in statistics and a lot of formulas with all of those symbols. So we'll just keep growing all of these symbols. But the ones we use in this first unit, you'll see all throughout the year in this course. So population is where your parameters come from. Remember, we're just going to keep emphasizing that. And then the statistic, that's from the sample. So we'll talk about mean, standard deviation, and variance. So from the population, the parameter for mean is the Greek letter mu. Write that next to it in case you mu. For standard deviation, it is sigma. And variance is just sigma squared. So if you see those Greek letters, you know, oh, this is coming directly from the population, okay? More commonly, you're going to see the sample statistic. And for mean, that is, we say this as X bar, X with a line over the top of it. Write that. Cool. Hold on. And then your standard deviation is just a lowercase s, and variance is just s squared. I think you can see from this chart that variance is just standard deviation squared. Okay, so whatever your standard deviation is squared, you get your variance. And these are for your quantitative data, your numerical or quantitative. Whereas the proportion down here, this is for your categorical data. Fewer symbols when we're talking about our categorical data. With proportions, your parameter is just capital P. So again, another one of the weird ones. It's not a Greek letter. In the statistic, this is P hat. It's a lowercase p with, well, a hat. So that's what your proportion is from your sample. All right, guys, how are we doing so far? Hanging in there? All right. Turn the page. We're going to try a few. Try practice problem here. All right, so first example here, we've got information about 10 randomly selected U.S. residents from the 2000 census. So we've got what state, how many members are in their family, their age, marital status, income, and travel time to work. So first thing we're going to do is identify the population of interest in this study. So guys, take a second, talk with your neighbor if you want to. What do you think the population of interest is? Be specific when you define a population, okay? Talk to each other. Write yours, check with your neighbor.
Yeah.
They said there's randomly selected.
Yeah.
Oh. That's okay.
So where do you go to get the ER?
Oh, okay, yeah. Okay, do you see it over there? Is there a phone anywhere around there?
Oh. I mean, I didn't see one.
Okay. It's a terrible feeling. All right, so you guys chat with each other? Anybody want to volunteer what they think the population of interest is? All right, go ahead. U.S. residents, okay, it's a good start. I would say not specific enough. Okay, pretty good. Yeah.
Not
Yeah, we want to make sure we include like what year this is. So I would say it's from the census, so that's all U.S. residents, right? So I would say all U.S. residents in the year 2000, okay? And this takes time getting used to how specific you need to be with these things. So. You know, and it can be worded slightly differently than this. It's interesting in statistics compared to other math classes you've been in. In here, you can have a very different answer than someone else, but if you support it and explain it, you can be correct. You know, in calculus, it's like, okay, you have to have that rounded to 3 decimal places, and if you're off at all, you're losing points. Here, you might be like, well, I found, you know, when we get more into calculating other things other than just mean and standard deviation, you might have 37 and you had 39.2. Okay, you're both, that's fine. Like, there's a lot of close enough in here, so it's very different from what you're used to in math. What were you going to say? I'm sorry.
Is England's a census that the entire population?
Yep. All right, so part B here, we're going to look at the variables that are measured, and then we want to identify them as categorical or quantitative. And then if it's quantitative, tell me what units it's measured in. So the variables are just the column headings along the top. We've got state, number of family members, age, all that. So I just want you to go along the top, like I would label state, okay, that's categorical, right? And remember, think about it. Can I average states? Doesn't really make sense. So definitely no, that's a category. So try to label all of those columns for me and put in the unit if it's a quantitative one. Guys, check with your neighbors.
Yes.
It seems like
I'm wondering how you can average so much.
Yeah, I don't know, but.
All right, do you guys agree? Yeah, okay. Number of family members, what do you think? Quantitative, good. Now units, number, I mean, it's not really, yeah, people, it's not a normal unit on that. So you could say number or people, I would take. Either of those. All right, what about age? Okay, and the category, or the unit? Okay, that one's a little easier. All right, what about marital status? Total income? Okay, unit? Okay, travel time to work, what do we think? Good, and our unit.
That's good.
Okay, so that's not too bad, right? We get the general idea there. Okay. Right. So let's look at the second one here. So we've got a car company doing some quality control testing. We've got this sample of 35 cars, MPG of 65.5. 11% of the cars experienced significant mechanical problems. That seems problematic there. In the first 30,000 miles. So I want you guys to try A, B, and C. So what's the population being studied? Be specific. Like, don't just say cars. Okay, that doesn't tell me enough. Identify the two variables. Are they categorical or quantitative? And then try to use anything in the text. Use some of those symbols that we did on the first page. So from this chart here, is there anything in the text that you could label with a symbol from the first page? Okay, so take a few minutes here and work on this problem. Guys, when you're done, go ahead and chat with your neighbors, see if you agree.
I said off last night. It's a lot I don't think so. I think it's like it's either one or because it's like that's because like and 11% accurate. Yeah, if you I don't know. So what would you say that the black parts what value is it? No,
I don't know.
We did write it on the first page there, but it's not in that chart.
Okay.
Look up above, see if you can figure out what it is.
Okay. It's a lower focus.
Good job.
Would you write it as like 11% when you're doing the value?
Wouldn't it be at the sample though?
Symbol, so would it be
Like out of the 35, saying on top.
Yeah.
would it be like blank over 35 or would it be just percent?
I would do just like
But
0.11.
what would that, which one is that?
Okay.
Is that the,
The p hat you'll usually write as a value
Is that the
between 0 and 1.
the miles per
that could be right.
It's not wrong if you actually like wrote out the fraction of it, but it's just easier to write. Okay, guys, let's go through them. Any thoughts on what the population being studied is? Patrick,
I said all cars that are part of the new unreleased line.
that's perfect, yeah. I was even lazier than that. I just said all cars in this new line, but yes, you're right, in the unreleased new line. So, all cars in this new unreleased line.
Do we have to be that specific, or could we just say the new unreleased cars, which we had in the line?
I would say in the line, just include that in there. You'd probably be okay with the other one too, but just err on the side of being more detailed. We're getting it. Did we do a better job on this one than the first one with labeling it? Yeah, okay. Just takes a little practice. All right, what are our two variables? Yeah, go ahead, dude.
Miles per gallon is reliability.
Okay, I just have like this paragraph written out for the other variable because like a weird category. So everybody okay with miles per gallon is quantitative? We get that? Okay. And then, yeah, the other one that's categorical, it's like, does it have a mechanical issue or not? You know, so I like the reliability. We'll call that a category. Like, problem or not a problem. Okay, and then identifying some of the values from the text and figuring out what symbol goes with them. So let's start with the sample of 35. What symbol goes with that? Yeah. Yeah, capital or lowercase?
Lowercase.
Good job, yes. So your sample size was n equals 35. Good work. Okay, then they told us that the sample yielded an average of 65.5 miles per gallon. That's impressive miles per gallon there. Yeah. Good job. So that is your sample mean. Okay. And that is X bar. Next is that 11%. What is that talking about? Yeah.
Like the categorical statistics.
Yes, exactly. Good. Yeah, it's like the proportion of cars with a problem. And that is P hat. There was a question up front here of, okay, like, do you have to write it as a fraction? Do you write it as a percent? What do you do? Usually when you write your P hat, you're going to write a value that's between 0 and 1. So we're going to write 0.11 for this P hat. Okay. So far, so good? All right. Okay, we got another one. So we've got new education initiative. So we've got a common assessment. They give you the national average for that. And then we've got a sample of 200 students and their average and the standard deviation. So again, identify the population being studied. And it should say what's the variable, what is the variable, not or the variable. That doesn't make sense. And figure out, is that variable categorical or quantitative? And then again, identify those values from the text and use their symbols. So I'll give you a few minutes here. Try this one.
Is it just one variable?
Yeah, there's just one variable this time. Poor grammar there in our notes. All right, guys, chat with your neighbor when you're ready.
Okay. When you said
I said other information. But I didn't know if I should add like the new education.
I think it works because I think but I think isolate. Is it important to add all things?
I would say like all students in this district. But you were right. You don't really need the new using this new because it's just all of the students in that whole district. So yeah.
And then I said test score quantitative. Yeah, I said I just also I just
The sample statistic. I do 4
which one samples?
because it's like the number.
Oh, I think it's just
Yeah. And then it's going to be and it's
and so that's what
it's an S.
It's a lot of like new symbols
Yeah.
to just sort out and go, okay, wait, which one?
Yeah.
Takes time. All right, guys. What do you think? What's the population being studied? Yep, I would just say all students in this district. You could say all students in this superintendent's district if you wanted to. That'd be fine too. But it is all students in this district.
Is it okay, like, if I say a district, are they still good out there?
Like, what'd you say? Sorry.
And all students in a school district? Or does that have to be one of the same school district?
I mean, since we're talking about this specific county superintendent and what he's looking for, I'd probably say his district. You're on the right track, though. All right, so there's just one variable being studied. What do you think, guys? What is the variable this time? Yeah, we'll go up to this.
The average test score. The average test score on the assessment.
Yep, so scores on this test, and what do you think? Is it quantitative? Yeah, good. This test. Okay, and then the values in here. There were quite a few of them this time. I'll just go through them. The sample size. So guys, what symbol do we use for sample size? Lowercase n, good. I think that was, what, 200 this time. They gave us the sample mean. What do we use for that one? X bar, good. X bar was 435. They gave us the population mean. What do we use for that? Mu. Yeah, that's the Greek letter one. We use mu for that one. Okay, that was 428. Okay. And then I think the only other one they gave us was the sample standard deviation, right? And what do we use when it's the sample standard deviation? S, good. All right, good. Questions on identifying any of that stuff? Okay. It'll just take you some time to learn all the symbols and just get really comfortable with them. So, all right, go ahead and turn the page when you're ready. All right, so we are going to do some constructing of graphical displays of data. It's not super common that you'd have a full free response question on the AP exam where you have to construct a whole histogram or anything like that. But it is fair game, it could come up. So we will practice and make sure you've got all of the pieces that you need for any sort of graphical display, okay? So first you want to make sure you always have the context. So you've got to label everything. So you put a title on it. I know I'm jumping ahead there. You have to label the X and Y axis. The key is needed because it's not clear what you're talking about. You want to make sure you include that. When you draw one, you don't want to have your graph go, okay, 0 to 50, and then the same spacing gets you to 60. You have to make sure that it's accurate. If you're going to make a jump in there, you can show that on your graph with, like, you can either draw 2 lines on it, kind of diagonal, or you can do this sort of like zigzag up and down. That indicates like, hey, there was a break in the scale here, and now I'm starting at whatever number you're starting from. Okay. So let's do a little simple one here just so you can see all of those pieces. So let's say we have some stat test scores. We have a 97, 94, 88, 81, and 75. So I'm going to make what's called a histogram, and we'll talk about that further down. Similar to a bar graph, but not exactly the same. What do you think the labels I'm going to use? What should I use? Okay, I want to display these test scores. All right. Well, maybe, yeah, Ethan. One side is test scores. Yeah, I'll put that down here. And then the other side, it kind of depends on what you want to show. We're going to show how many students got each of these test scores, okay? So we'll call this side number of students. All right, so if I wanted to make sort of columns of these, it looks like we have one score in the 70s, 2 scores in the 80s, and 2 scores in the 90s. Well, I don't want to start at 0 and go all the way to 90 on the test scores. So this is where I would use one of those little indicators that, hey, there's a break in the scale. And now I'm going to start 70 to 80, 80 to 90, and 90 to 100. And now when I'm making a histogram, you're not just plotting each individual score. You're plotting it like within a group. So I see that I have one score between 70 and 80. So I would just make this bar of my histogram go up to the 1. Okay, and then I see that I have 2 scores from 80 to 90. So I would make this one go up to 2. And then I also have 2 scores between 90 and 100. Hopefully yours are uniform in size a little more than mine are. But. All right, am I missing anything on my graphical display of my data here? Title, yes. I would just call this stat test scores. So just somewhere up here you could do stat test scores. That's just a quick example of a way you can graphically display your data. There are several different options, and whether you have quantitative data or categorical data to display, you have different graphs that you use, okay? So that's a histogram. We'll go into more detail with the histogram down below, but that's, you know, gives you the idea of pieces that you need. You've got to label everything and be accurate with, you know, the sizing on your scale there. All right, so we're going to start by looking at the different ways we can display quantitative data, okay? And the first way we're going to do this is with the frequency table. And we're going to look at the age from that first practice problem from the census where I gave you all the different columns of information. We're going to look at age. So what I'm going to do is make some different groups that their ages might fall into. So the first one I'll say is from 20 to 30. And you do want to specify, you know, because the next group's going to be from 30 to 40. Well, we want to specify where does the 30-year-old person go. They can't go in both of these groups, so we want to know which one do they fall into. So you just, on the first one, you'd want to say, like 20 is less than or equal to X is less than 30. So if you're 30, you're not going in that first group, you would go in this one. You could label it too if you want. 30 less than or equal to X is less than 40. You know, so you've got the idea there. And when you're making these little groups that they could fall into with ages, you want to be consistent. We don't want to have 20 to 30, that's 10 years, and then go, okay, now I'm just going to go 30 to 35 and have that one only be 5 years, and then do another one that's 20 years. You don't want to do that. You want to be consistent with the size of these groups. So we've got 30 to 40, then we'll do 40 to 50, 50 to 60, I think 60 to 70 is the last one we need. So we're making a frequency table of this. So the next column is the frequency, okay? That just means we're going to look and count from the information you got on the previous page, how many people fit into each of these groups. So go ahead and just look back at that chart on the previous page at the top. Look at the ages and see how many fall within each group. And there should be 10 people total. Once you're done, check with your neighbor, make sure you counted right.
You get a
All right, I've heard a lot of 4, 3, 2, 0, 1. That is correct. Okay, so double check if you had any of those off. How many fall into each of those groups? Okay. It's a frequency table. We've already done the frequency. We've got a lot of columns left, so we're going to do some other things with that. We can find the cumulative frequency. So what this is talking about is kind of combining groups here. So the first group is still 20 to 30. There's 4 people in there. That's all we have. Next, we're not just going to count the 30 to 40, though. We're going to go 20 to 40. So you always start at that original group. So what do you think the next little box here is going to be? 7. Okay. For the next one, we're going 20 to 50. 9, 20 to 60, still 9, 20 to 70, 10. Okay, so you're just getting that total built up there. All right, then we're going to do relative frequency. Relative frequency is just looking at each group out of the whole. So 20 to 30, that would be your relative frequency is 4 out of 10.
Can you simplify that?
You can, you don't have to though. So then the next group would be 3 out of 10, 2 out of 10, 0 out of 10, and 1 out of 10. And then our last column is cumulative relative frequency, okay? So the first box will be 4 out of 10. What do you think the next one will be?
7 out of 10.
There you go, 7 out of 10. 9 out of 10. 9 out of 10. And 10 out of 10, okay? It just doesn't sound good over there, does it? I'm worried it's gonna die. The one in that room died. I don't want this one to die. All right, guys, so any questions on frequency tables? We don't use these a ton, but it's good to be able to read it and understand what it's telling you, okay? But you're not going to create these on a regular basis. Okay, histograms. So one note with a histogram, I know we made a quick little one up above. It's not the same as a bar graph. And we'll get to bar graphs. In my histogram up here, the bars that I have in my histogram, you can see how they're right next to each other, like they touch each other. There's no spaces. If there was a space in between bars, that would indicate like no data values in that section. Whereas in an actual bar graph, you purposely have space in between your bars. Okay, that's like the biggest difference. Also, these are used for quantitative data, and bar graphs are only used for categorical. Okay. All right, so let's take the ages we just looked at and make a histogram out of that. Okay, so what you just put into the relative frequency table, I want you guys to try to draw a histogram for me. Take your time with this. I'm not going to rush you through it. Think about all the pieces you would need in there.
Yeah.
Make it nice and neat. Take your time.
See, I need to say that it's like evidence, like if this certifies it's not even just. Okay, perfect, yeah. Yeah.
Guys, go ahead and look at your neighbors. I'll draw one up here so we can kind of make sure we're all on the same page. See if you and your neighbor have all the details you're supposed to have. Guys walking around, the thing that was commonly missed is you guys would forget to put the title on it. It's so easy because you're labeling, you're doing everything, and you just forget that one last little piece. And be specific with your title here. I would say something like ages of U.S. residents. Sampled from the 2000 census. You could even go back and just use like what it said in the problem up here. You could say like, 10 randomly sampled U.S. residents from the 2000 census. You could certainly use that as your title too. Really just rolls off the tongue for the title of your histogram there. Be detailed. Don't just say like U.S. residents. Okay, that's not really what it is. It's this sample from the 2000 census. Okay. We're going to get into describing our distributions here, and we'll talk about the shape, which you can see from the histogram. Another benefit is it's easy if you have a large set of data. because you can just kind of throw them into these little groups, and it's just much quicker than trying to plot all of the individual values if it's a large data set. But in doing that, you do lose those individual values. So we can look at it and go, oh, we had 4 people, which I didn't label those. 1, 2, 3, 4. We have 4 people between the ages of 20 and 30. But we have no idea what their ages actually are. Okay, so it's kind of a trade-off of ease of creating it, but losing some detail. And it's nice, you get a very good visual of, okay, there's a gap from 50 to 60. Like, I didn't have any people in that group. It's easy to spot that when it's in a histogram. Okay? Any questions on histograms? Let's go ahead and turn the page. All right, we have box plots or parallel box plots. These ones are created vertically. You can create them horizontally as well. Your calculator can create box plots for you. It can create multiple box plots. They usually do them horizontally, just so you don't go, wait, what's happening here? It's okay if they're vertical or horizontal. A benefit here, it's kind of nice when you're comparing data sets. Like, it's really easy to see how some of the pieces line up. You can see some of the shape. You can see, you know, like, wow, the dramatic difference between this group and the first group. And we'll talk about what that whisker means later. But it's nice for nice for comparing data sets, okay? It also gives you a good visual of outliers. Now, you don't know what an outlier is. You know the idea of an outlier, but we haven't formally defined that yet. So it helps you see if there's some value that really doesn't fit with the rest of your data. You know, I said your calculator can create these. Your calculator can also create your histogram for you and draw that out for you. So that's really helpful. You still have to put it on your paper sometimes, but it's nice when it can take your whole list of data and create it for you. Next class, we'll probably look at doing some of these things on your calculator and how you can create some of these displays. So bring your calculator next time. Start bringing that every time we have class, because we do use it a lot in here. Okay. All right, some other key things with your box plots here. Again, it's useful with large data sets. It's really easy to just have your whole list in your calculator and boom, there's your box plot. But just like with the histogram, you do lose the individual values. We know what percentage of our data values are within each little section, but we have no idea what the actual values are. Okay. So your 5-number summary, that is the minimum. And then Q1, I'm abbreviating all of these, so bear with me. Q1 is the first quartile. And then there's the median. And then there's Q3, which is the third quartile, and the maximum. I'm going to draw a box plot for you here just so we can kind of label these things. When I draw them, I always draw them horizontally. I don't know. It's just how they should be in my mind. So that is a box plot. Sometimes they're called box and whisker plots because those are the whiskers sticking out on the end. The farthest value on the left, that is your minimum. And then the left edge of the box, that's where the Q1 is. The median is in the middle. 3, label those 4 tile. 3, sorry. And then farthest right, that's going to be the maximum. So what's nice with a box plot is you can see percentages of your data. So each little section here, so like this first part, that first whisker, that contains 25% of your data. And then that's the same with each section from there on out. So the first half of the box is 25%. And then 25% for the second half, and that last whisker is the final 25% of your data. So if we go back up to the top here, and you look at some of these, so like this one on the far right with this really long whisker, you know, that's where 25% of the data is, but it's really spread out. Like you can see, because that whisker is so long, like, oh, we've just got the, you know, a few of them really spaced out. Whereas if you look at this first box and whisker plot, like, my goodness, those data values are all like really close to each other. So it just gives you a nice visual of what's happening there and how spread out your data is. Questions so far? I know it's a lot. Day 1 of notes, it's just long. We'll get through it. Okay. Still with our quantitative data, we have stem and leaf plots. So I have examples for you here of a just regular stem and leaf plot, a double stem and leaf, and a back-to-back double stem and leaf. So combining all of them. So the stem and leaf plot here, this first one, you're always going to see a key when you have a stem and leaf plot. We can see down here, it says this 2 with the line, and then 2 represents 22 pairs of shoes. So you can take each of these values and you could recreate the original data points. So like, if I look at just this group here, 04, that's 4 pairs of shoes. I think we're looking at shoes, yeah. 05, 5 pairs of shoes. There was another 5 pairs, another 5 pairs, 6 pairs, 7 pairs, 7 pairs, 7 pairs, 7 pairs, 8 pairs. And then you can see we had 10, 10, 10, 10, 11, 12, 14, 22, 35, and 38. Does that make sense how you read those numbers from it? Okay. So it's faster than writing out every single number, because you just write the initial number one time. But it still takes a bit of time. Like if you had a really large set of data values, this wouldn't be super fun to do. But the flip side is you still have the exact numbers. They aren't lost. You know, we've talked about it's the trade-off between the ease of creating it and keeping the specifics in there. Okay. The double stem and leaf, this you're going to want to use if a certain leaf is getting really, really long, you might want to break it down. So you can see we've got 2 zeros happening here. Usually the first is like 0 through 4, and then the next group would be your 5 through 9 on the leaves. So it's just taking those same values and splitting them a little more so you can just group them in a different way. It doesn't really like reduce what you're writing. It actually creates more for you to write. But sometimes it helps you sort out the shape of your distribution a little better if you split it up like that. And then the far right one here, this back-to-back double stem and leaf. So we've got the double. You can see that in the middle, because you've got your 0, 0, 1, 1, 2, 2, all of that. And then the back-to-back part of it is instead of this one group, we're using females on one side, males on the other. So if I look at the female side for the number of shoes, this isn't saying 31, 31, 31. Okay, that's saying 13, 13, 13. They're sharing that stem, if you will. And over here it's 10, 10, 10, 10, 11, 12. Does that make sense? So you have to kind of read backwards on one side. So this is 38 pairs of shoes. This is 57 pairs of shoes. Okay? All right, so that's, you may have to create like a back-to-back stem and leaf plot at some point, and so you just have to have your two groups on either side. Okay? Your calculator doesn't make these for you, so that's not very nice. You just have to do those by hand. And again, we kind of talked about this. You can see the shape in there. You do keep those individual data values, but it's not super fun if you have a big set of data. Then dot plot is another one. This one's nice just because it's so simple. Like if I'm ever collecting data from something in class and I need to, you know, throw it up somewhere quickly, it's faster than a histogram because I don't have to make like these nice bars. I can just plot it. Like if I don't know, if we did number of shoes like the last one and I asked you guys how many you had and I wanted to just fill this in, you know, instead of making those different bars, it's like, okay, I had a 10 and then two 12s and an 11 and a 13, another 12, a 14 and another 14. Like it's really quick to build it when you're in the middle of collecting the data, okay? So it's nice, it's super simple. It's also very easy to see the shape of your distribution, okay? The next class we'll get more into describing the shape. We're not going to do too much more today, guys. Let's just finish this page because this is the last of the quantitative, and then we'll stop there for notes today, okay? All right, so we have a time series graph. You don't see these a lot in here, but you do need to be aware of what they are. You want to be able to interpret them. What makes it a time series graph is that time is always the horizontal axis. So always, always, always. And the difference between this and just like a scatter plot that you might do is the dots are connected. So if it's a time series, the dots will be connected. And then the last one we'll look at here is the cumulative relative frequency graph. So we made a table with our cumulative relative frequency earlier, and you know that was kind of like growing throughout, like you were adding until you got to every person being used. So it's the same idea in this. It's called an ogive too. But you can identify percentiles nicely with this. I'll give you an example. So let's say I wanted to look between 40 and 60%. And I know my lines are not awesome here, but pretend that that's where that goes. I could say, this is all about length of call. I could say 20% of the calls are between 15 and 20 minutes long. Okay, so like you could look at a certain section and say this percentage of whatever we're talking about is in there. Or just one more example from it, I could say something like about 40% of the calls are 15 minutes or less in length. Does that make sense how I'm reading that from that? Okay. It's just kind of a different type of graph for you guys to look at. Okay, so let's stop there with notes and then we'll pick back up with categorical displays next time. Good work, guys. Hung in there. We've made it through a huge chunk of Unit 1 already. You still got about 5 minutes until the bell's going to ring.